everyone! Today I'm going to teach you about transferring electrical energy to light energy. I'm going to start by building a circuit. A circuit is a path which an electric current can flow through. An electric current is a flow of electricity. To build my circuit, I have a few materials. I have this battery, which is the power source, and I have a light bulb in this holder. I'm going to connect those with these two wires. I'll start by connecting a wire to the positive side of the battery and then to the holder where the light bulb is. But my circuit isn't complete yet. I have to also connect the light bulb holder to the other side of the battery. What I have right now is called an open circuit. That's because there's a break in the circuit that needs to be closed. If I connect the wire to the other side of the battery, the light bulb should turn on. And it did. Our light bulb has turned on because the circuit is closed. Energy is flowing out of the positive side of the battery to the light bulb, and it returns to the negative side. Now, batteries have chemical energy in them that are converted into electrical energy. And when that electricity flows through the wire, it transfers to light and heat energy in the light bulb. We have a closed circuit and our light bulb is on. What we have here is called a closed circuit. That means there aren't any breaks in the circuit. The wires are all connected and the energy is going from electrical energy to light energy. Now, if I open the circuit back up again, that means the light bulb is going to turn off. Now I have an open circuit again, and I can actually close that circuit with something else called a conductor. A conductor is a material that an electric current can easily pass through. I have an open circuit that I would like to close with a conductor. So I actually collected a few materials throughout my apartment that I thought might be conductors that would help me close my circuit. The first one I'm going to try is a key. Now, if this key is a conductor, that means that it will close my circuit and the electric current will be able to flow through it from the wire to the light bulb. Let's see if this is a conductor. The key was able to turn on the light bulb by closing the circuit. That means this key is a conductor. The next thing I'm going to try is my ring. And no, I'm not married. If this ring is a conductor, that means that electric currents can easily pass through it, and it should be able to close my circuit. Let's find out. I'm going to hook the wire to my ring, and then if I touch the ring on the holder, let's see if the light bulb turns on. It does. I have now closed my circuit, the light bulb has turned on, and my ring is a conductor. Now, what would happen if I tried an item that wouldn't close my circuit? That would be called an insulator. An insulator is a material that an electric current cannot easily pass through. Now I'm going to test my chapstick. What do you think? Is this chapstick an insulator or a conductor? I think it's probably an insulator. I don't know if an electric current can really pass through my chapstick. Let's see if I can successfully close my circuit with this chapstick. I'm going to attach the wire to the chapstick. Now, if it's a conductor, that means that it will close my circuit and the light bulb will turn on. But if it's an insulator, that means that it won't close my circuit and the light bulb will stay off. The light bulb hasn't turned on. That means that this chapstick did not close the circuit. The circuit's still open, the light bulb hasn't turned on, and that chapstick is an insulator. Before we move on, I wanted to add something about my chapstick. This chapstick is an insulator for two reasons. The chapstick inside is an insulator, but the plastic container is also an insulator. So it wasn't able to close our circuit because the plastic container and the chapstick are both insulators. Next, I'm going to make things a little bit more interesting by adding a switch to my circuit. A switch is a device that can open and close a circuit, kind of like a light switch, which you use to turn lights on and off. That's what we're going to do now with our circuit. Here I have my switch. Now, sometimes switches might look a little bit different. It might just be a button you push on and off, or it might be a light switch which you push up and down. Here's what my switch looks like. Now I'm going to use another wire to attach my switch and add it to the circuit. Right now I have an open circuit, but if I close it, the light bulb should turn on again. The light bulb is on. That means that electricity is turning into light energy. And now I'm going to use my switch to turn the light bulb on and off. Right now the light bulb is on because the circuit is closed. But if I do this with the switch, the light bulb turns off. That means that the circuit is open. Closed circuit, light bulb on. Open circuit, light bulb off. Closed, open. We've covered a lot so far, so let's take a minute to review. First, I built a circuit. That circuit helped me transfer electrical energy to light energy through the electric current in the wire. Next, we talked about conductors and insulators. A conductor is a material that an electric current can pass through, and that lets us close the circuit. An insulator is a material that an electric current cannot easily pass through, and it does not close the circuit. After talking about conductors and insulators, I added a device to my circuit called a switch, and that switch is used to open and close a circuit, just like this. Now let's talk about how circuits are used in real life. Now, circuits are actually used in a lot of ways, but today we're just talking about lights. In every light you use, whether it be in a classroom or at home in your bedroom, that light is powered by a circuit. The circuit transfers electrical energy to light energy, and usually those lights have switches. That switch is used to turn the light on and off. When the switch is on, that means that the circuit is closed. When the switch is off, that means that the circuit is open. Now, you can't actually see the circuits because they're usually hidden behind a wall, but you can see the switch. So I'm going to go on a scavenger hunt in my apartment and see what kind of switches I can find. This one was pretty easy to find. It's a light switch. Now, right now, the switch is off, and so is my light. That means that we have an open circuit that needs to be closed. I can close the circuit by turning the switch on. Now, my light is on, and my circuit is closed. The next one was a little bit harder to find. It's in my refrigerator. Now, did you know that when you open your refrigerator, the light turns on, but when you close your refrigerator, the light turns off? Here's how that works. There's actually a switch. Now, right now, the light is on, and that means the circuit is closed. But if I press this switch, the light's gonna turn off. And now we have an open circuit. So this is just another place in my apartment where electrical energy is transferring to light energy, and the circuit is closing and opening because of that switch right there. So every time you open and close your refrigerator, you're also opening and closing a circuit. All right, everyone, I found one more switch, and now things have gotten really interesting. This light switch is actually connected to my lamp that's all the way over there. Now, that means that the light switch is connected by electrical wires to this outlet over here. And the outlet has the lamp plugged into it. So, not only can I control the lamp by this switch right here, I can also control the lamp by this switch over here. Here's what's interesting though. If the circuit is open on this switch, I can no longer control the lamp using this switch. The lamp isn't turning on and off, and that is because the circuit needs to be closed on the lamp and on the switch. Pretty cool, huh? So, today you learned how circuits transfer electrical energy to light energy, and how switches are used to open and close the circuit. Now be sure to go check out my activity on Google Classroom so that you can show Miss Connolly and I everything you learned about circuits, switches, conductors, and insulators.